All right, today we're going to pull back the curtain on a really fascinating piece of AI engineering. We're going to look at a system that's built not just to do things, but to actually learn from its own mistakes and upgrade itself permanently. This isn't just about getting an AI to work, it's about building an AI that literally never makes the same mistake twice. Let's dig into how they pulled it off. And this all really boils down to one huge question. Can you have an AI that's both wildly creative and perfectly consistent? We love LLMs for their spark, right? But for any business that needs things done the exact same way every single time, that creativity can start to feel, well, a lot like unreliability. So, how do you get the best of both worlds? So, before we jump into the solution, we have to really wrap our heads around the problem. At its heart, this is all about a major conflict. You've got the creative, kind of unpredictable nature of an AI on one side and the rigid, rule-based world of business on the other. And this slide just nails the analogy. Think about it like this. The LLM is your brilliant creative artisan. The stuff they make is incredible, but you can never be 100% sure they'll do it the same way twice. Then you have your business logic. That's the assembly line. It has to be reliable, testable, and perfectly consistent. These two things just don't naturally play well together. And this right here shows you what happens when that conflict hits the real world. You might think, hey, 90% accuracy for one step, that's an A-, right? Pretty good. But look what happens. When you string 5 of those pretty good steps together, your overall chance of success absolutely plummets to just 59%. For any serious business process, that's not just bad, that's a complete failure. So how in the world do you fix this? Well, you don't try to change the artisan. No. Instead, you build an entire factory around them. And that factory, that's the code framework. It's a whole architecture designed to give that creative AI the structure and the rock-solid reliability it's missing. The real magic of this framework is how it's split into 4 distinct layers, and each one has a very specific job. Together, they spell out code, context, operations, directives, and execution. Think of it as the different departments of our AI factory. Let's take a quick tour of the assembly line. First up, you've got C for context. This is basically the factory's brand Bible. It's where all the client-specific stuff lives, their unique voice, their data, their brand guidelines, you name it. By keeping the identity of the work separate from the process of the work, the factory can switch from task to task or client to client without ever having to change its core machinery. Super smart. Next is O for operations. Now, this is the AI, but it's acting as the factory's floor manager. And its only job is to look at the context, read the directives, the instructions, and then figure out which tools to grab from the toolbox and in what order. It doesn't actually do the work itself, it just intelligently routes the work. The D stands for directives. This is the factory's official instruction manual. And the cool part? These aren't written in some complex code. They are basically standard operating procedures, written in plain English. They tell the AI exactly what the goal is, the steps to follow, and which tools it's supposed to use. Simple and clear. And finally, we have E for execution. This is the robotic assembly line itself. It's a whole library of simple, totally reliable, deterministic Python scripts. These are the specialized tools that the operations layer calls on. Each one does one thing, it does it perfectly every single time, and it just doesn't fail. Okay, so you've got this incredibly robust factory. It's organized, it's efficient, but here's where things go from clever to absolute genius. The system is designed to learn and get better all by itself. This is what the creators call its self-annealing superpower. So what on earth is self-annealing? It's actually a pretty simple but incredibly powerful idea. You treat every single error not as a problem, but as a chance for a permanent upgrade. Instead of just fixing something for one task, the system is built to capture that solution and basically write it into its own DNA forever. And it all happens in this simple 3-step learning loop. First, anytime there's an issue and a fix, it gets logged meticulously. Second, before the AI starts a new job, it checks those logs. It asks, hey, have I seen a problem like this before? And third, and this is the absolute key, once the task is done, the main instruction manual, those directives we talked about, are permanently updated with that new knowledge. The results? Well, it's summed up perfectly by this quote from their own documentation. Each issue fixed once, reused forever. You're not just swatting a bug for one project. You're basically vaccinating the entire system against that problem for every single task in the future. Okay, that all sounds amazing in theory, right? But does this AI factory actually deliver the goods? Let's take a look at the actual numbers for a pretty complex content creation task. The data here is, well, it's pretty staggering. Just look at this. A process that used to take a human 7 full hours, creating content, getting it all processed, publishing it, is now down to just an hour and a half. And look at the content and notebook LML steps. Completely automated. 0 hours. If you want to put a single number on that, it's a 79% reduction in the time it takes to get the job done. I mean, come on, that is a massive, massive gain in efficiency. But here's the thing. The benefits go way beyond just pure speed. Because that execution layer is built on rock-solid deterministic code, the system can actually enforce strict, non-negotiable quality standards on everything it produces.
For instance, when it creates a blog post, it can provide a set of absolute guarantees. The audio player is always at the top. The promo section is always right after it. The right tags are always applied. These aren't just suggestions for the AI, they are hard-coded rules that guarantee a perfect, consistent result every single time.
So let's just zoom out for a second and think about what this really means. This kind of framework is a pretty significant shift in how we can actually use AI inside a real business. Really, the most important takeaway is this. The code framework manages to turn a creative, sometimes unpredictable tool into a reliable, totally deterministic business asset. It gives you insane efficiency, it's scalable because it literally gets smarter over time, and it's traceable because every single lesson it learns is documented and reused forever. And that kind of leaves us with one last really interesting question to chew on. We're all used to our tools getting better when a developer pushes an update, right? But this system, it points to a future where the tools we use every day get smarter, faster, and more reliable all on their own, just by doing their job. What does that future even look like?